Good morning, everybody. Welcome to Homework Helper for section 2.1. Let's go ahead and get this thing started. I'm actually going to do 2.1 and 2.2. Why not? All right, so for the first section, it wants us to find the key features of the graph of this quadratic equation, which in this case is a parabola. It wants us to make a point on the vertex, and remember the vertex is the switching point. It's going to be the tip of our parabola. It wants us to draw a dotted line of the axis of symmetry. It wants us to label the coordinate of the vertex and state whether it's a maximum or minimum. And then it wants us to write the equation of the axis of symmetry. So it wants us to do a lot of things. So I'll go ahead and do that real quick with number one. So make a point of the vertex. Well, here's the vertex. Boom. Draw a dotted line on the axis of symmetry. Well, it cuts it in half at the vertex. So there's my dotted line. Label the coordinates of the vertex. Okay, so this is the point 0, 0. And state whether it's the maximum or minimum. Well, it's the lowest value because it goes up from there. So this is the minimum. And then finally, write the equation of the axis of symmetry. Well, this is a vertical line. All vertical lines are going to be x equals, and in this case, it's where x is 0. Okay, so that's how we would do that. I'll do one more just to make it clear. All right, so make a point of the vertex. Here it is. Draw a dotted line for the axis of symmetry. Here it is. Label the coordinate. Okay, so this is, my x is 4 and my y is 0. So it's 4, 0. It is still a minimum. And the equation of the axis of symmetry is x equals, and this time it's x equals 4. Okay. So notice some things. Notice that our x value and our equation are very similar. So keep that in mind as we move forward with that. Okay, next section, set. So we're talking about transformation of quadratic. So we're trying to figure out what each of these means in terms of everything else. So when we're looking at like an x squared is going to be our area. It's going to be our initial square. Right? That's why it's called squared. Squared. Okay. So when I'm thinking about this problem, I see that we're doing different things to the x at each step, but I'm always going to think about the x squared. This is the x squared right here. This is x squared. This is x squared. This is x squared. And then this is x squared. And so when I see x squared plus 4, that means I have a square plus 4 units. Which of these looks like a square plus 4 units? Well, that's this one. It's D. This is a square plus 1, 2, 3, 4 units. Now this one is x plus 4, then squared. So if this is my x, do I then add 4? Not really. How about this one? X, then 1, 2, 3, 4. Yes. And then I square it, creating this big square. So this would be B. And so on and so forth. So you just kind of have to look to see what each of those things is actually doing. Next. Go. Ooh, finding square roots. So this one's fun. I think it's fun. I'm getting a dirty look from a student that's working in here when I said that. But so what we're finding here is we want to find our square roots of each of these. Now square roots are super cool. What it asks us to do, let's clear that. No, I don't want that. Ooh, okay. What it asks us to do is figure out what times what is the thing underneath this radical. That's what we call this shape. This is the radical. Okay? So it wants us to figure out what times what is this. So what times what is 49? Well, we should all know our times tables by now to know that 7 times 7 is 49. So I know that radical 49 is the same thing as 7. Because that means that the square root of 49 is 7 because 7 times itself is 49. Okay? What about a squared? What times itself is a squared? Well, in this case, we know that a times a would be a squared, right? The radical of a squared would be a, because a squared would be a squared. So we know that we have a 7a, but now it gets a little bit tricky, because now we have b to the 6th. So what's the square root of b to the 6th? What times itself is b to the 6th? This might be a little bit more confusing. So whenever we're hit with something that's a little bit more confusing like this, what I like to do is I like to make a little factor tree. Okay, so I know that b6 is really b times b times b times b times b times b, 6 of them, okay? And when I look at this, I can see that if I have this times this, well, that would be b cubed squared. So really, radical b6 is b cubed. So my final answer would be 7ab cubed. Another way you can do this, this is going to be a little tricky, so follow with me. So when we're square rooting something like b to the 6th, we don't write this, but really there's like a little invisible 2 right here, because we're taking the square root, we're undoing squaring. So really what we do is this is the same thing as if I were to take b to the 6th power, 6 halves power, okay? If you just take whatever this is, whatever this exponent is, and divide it by 2, you will get that square root. So in this case, b to the 6th divided by 2, well, 6 divided by 2 is 3. So I know that the radical of b to the 6th is b cubed. Okay, this is just a nice little trick. When I look at something like this here, well, look at this, x plus 13 squared. Well, if I were to undo that squaring, I would just have x plus 13. Done. That one's pretty neat. That one's pretty easy. It's kind of fun. Okay. So, with all of that being that, let's go ahead and go to 2.2. All right. So for 2.2, it wants us to play with the standard form of the quadratic equation where y equals ax squared plus bx plus c. And the thing that I want you to note is that these have to be in order, descending order, where it goes x squared, then x, then our constant. Okay? So just kind of keep that in mind. And where a is not 0. So we have an x squared term. So pretty much all we have to do is just identify the a, b's, and c's. Okay? In this case, a would be the number attached to the x squared, so 5. B is the number attached to the x, which is 3. And c is the constant, which is 6. Okay? But let's go to one that's maybe a little bit more complicated. When I look at something like 4 here, okay, so y equals 6x squared minus 5. Well, a is the number attached to the x squared, which is 6. B is the number which is attached to the x, but I don't see an x term. It's not there. Well, that means I have 0 x's. So my b is 0. And then finally my c term, it says minus 5 here. Make sure you include that negative. It's negative 5. Okay. Next, this next section asks us to do a little bit more playing with it. It wants us to multiply it out and then write it and identify the a, b, and c. So here, I'd have to distribute my x squared, or my x giving me an x squared. You can see I'm already jumping the gun a little bit, minus 4x. Okay, so now my a is 1, my b is negative 4, and my c is, I don't have a c, so it's 0. So you'll do that, you'll see that we have to do some foiling, et cetera, to be able to do these. But then you want to identify what your a, b's, and c's are. Make sure you combine all of your like terms. For our set, it's asking us to kind of play with parabolas a little bit more. So include at least 3 accurate points on each side of the axis of symmetry. Okay, so it pretty much just wants us to graph a standard parabola. So I will do that. Okay, so I was about to build a table, but it gives me a table right here. But I know that my vertex is 0, 0, because when I plug 0 in for x, 0 squared becomes 0. Okay, 1 is 1, because x squared, right, because this would be x squared, which would be 1 squared, which would be 1. Okay, and the same thing here for negative 1. Negative 1 squared is 1. Okay, so I know that 1 is 1 and negative 1 is 1. Next, I'll do the 2's. I know that 2 squared is 4, and I also know that negative 2 squared is still 4. So 4 and 4. So 1, 2, 3, 4. And likewise 4 over here. And then for 3, 3 squared is 9, but also negative 3 squared is 9. So 3 is 9, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And likewise over here 9. Okay, and there's my parabola. There's my parabola. My vertex is at 0, 0. And it says include at least 3 accurate points. Let's actually include those points. This is 0, 0. This is 1, 1. This is 2, 4. And this is 3, 9. And this is negative 1, 1. And this is negative 2, 4. And this is negative 3, 9. Okay, and there's my parabola.
We're doing cards again?
So let's go ahead and go to the next section. Did I skip a section? Nope, I did. And so this time it's asking us to do the same thing with parabolas, except we're not given a we're not given a graph. Instead, we're just given the table. So we still need to be able to figure out what's going on just from the table. So one of the things that we should be doing is looking for the axis of symmetry. Okay, it says identify the vertex and the axis of symmetry. So what we want to do is we want to be able to see where that's happening. And one of the ways that we're able to do that is to see where it starts to mirror itself in our y column, right? That's going to give us an idea of what the vertex and axis of symmetry is. So I see that it goes from 10 to 3 moving down, 3 to negative 2 moving down, negative 2 to negative 5 moving down, negative 5 to negative 6 moving down, okay? So I see that this is all downward motion all the way here. But when I get to here, it starts to go up to negative 5. Negative 5, negative 5. I see I have my mirror point. So I've identified my vertex. This is where it begins to mirror itself. So my vertex is the point 0, negative 6. The axis of symmetry is just x equals whatever my x value is at my vertex. So x equals 0. X intercepts. So the x-intercepts are where y equals 0, right? Because remember, this would be our x-intercepts, would be here and here. It's where y equals 0. So where does y equals 0 here? Well, it equals 0 somewhere between negative 2 and negative 3. And likewise, we can assume, going the opposite way, between 2 and 3. Okay? So the x-intercepts are going to be somewhere between negative 3 and negative 2, and also, whoops, there's got to be an easier way to do that. Oh, it just says the number of them. We don't have to identify them. Well, there's 2 of them. That's good, because it's fractional. And then finally, is the vertex a min or a maximum? Well, it goes down to negative 6. That's our lowest number, so it's the minimum. Sweet. And that's going to be your homework. Good luck, woodchucks. Do your best, and I will see you tomorrow.